So in the next lesson for section 4.2, we have notes on pages 81 through 85, and what we're doing here is comparing linear functions. So all of these are functions and they're all linear, so they're going to be in slope-intercept form, so we can compare two equations in slope-intercept form, or we can compare two tables or a table and a graph. We can compare in different ways. So the first example asks who will have $100 first, George or Mark. So George has $20 and is saving $15 every week. Mark starts with $20 and his savings are shown on the graph below. So he starts with $20, that would be his y-intercept, and he's saving at a rate of $10 per week. If we look at George, we can write George's equation is y is equal to 15 times x plus 20. $20 is where he started, and he's saving $15 each week. Here I've put it in a table. So the conclusion is that George will have $100 first. It will take 6 weeks, and Mark won't have $100 until week 8. We can see, we can actually continue going on the graph, and that will show us. We can also look at the equations. Who is saving at a faster rate, George or Mark? George is saving faster or more money each week, therefore they both started with 20, so George is going to get to $100 faster. So now we're putting the cyclists in order from slowest to fastest. Note the variables are x equals time in seconds and y equals meters traveled. We've discussed before what depends on what. So time goes by and then the meters traveled depend on the time that goes by. Time doesn't go by because we've traveled meters in a distance in meters. So we can compare cyclist A, and so I took this table and we found the change in y over the change in x. I found my y-intercept, which was 0. So my equation is y is equal to, and this would be 1 meter every 2 seconds. Cyclist B, Bob has cycled 12 meters in the past 6 seconds, so that would be our slope, 12 meters in 6 seconds. That would give me a rate of 2 meters per second. Cyclist C goes at a rate of 1 meter every 3 seconds, and cyclist D goes at a rate of 2 meters every 3 seconds. So we can put these in order from slowest to fastest. So cyclist C is slowest at a rate of 1 meter every 3 seconds. Cyclist A is second slowest because they go at a rate of 1 meter every 2 seconds. Cyclist D goes at a rate of 2 meters every 3 seconds, and cyclist B is the fastest at 2 meters per second. Let's look at the next part. Part 3, assume the rates below will remain constant. Who will win the hot dog eating contest and why? So Helga, who has eaten 18 hot dogs in 5 minutes. So that is a rate of change, a slope. So m is equal to 18 over 5. So Helga is going to eat 3.6 hot dogs every minute. Pablo, who is eating a record, is shown below on this graph. So he starts off with 0, and in 1 minute he eats 4 hot dogs. So his equation is right here, y is equal to 4x. So if I compare the rates, the slope of 3.6 hot dogs a minute to 4 hot dogs a minute, Pablo will win the hot dog eating contest. He eats 4 hot dogs per minute, and Helga eats 3.6 hot dogs per minute. So Pablo, doing some good hot dog eating there. All right, this next one, based on the information below, which bathtub will be empty first and why? So right here we have bathtub A. It starts off with 25 gallons and is draining 1.5 gallons a minute. So 25 is where it starts. I put this in fraction form. so that we can compare everything in fractions. So -3/2, that would be 3 gallons every 2 minutes, which is the same as 1.5 gallons a minute. Bathtub B, we have a table. So again, we can find our slope or our rate of change. It starts at 25 gallons as well and drains at a rate of 5 gallons every 3 minutes. So we can compare this equation here to this one. And the next one, we have a graph. So here we would be at 25 gallons is where it starts. And as I keep going, I can see, if I look, I'm going down my distinct points. I'm looking for my distinct point here. It's actually right in the middle, kind of in here. So we're going down 4 gallons. If we go to 20, oh, it's right there, 21/3. So we're going down 4 gallons every 3 minutes. So if we compare, bathtub B will empty first. It drains at a rate of 1 2/3 gallons per minute, which is faster than tub A, which is 1.5 gallons per minute, or tub C, which is 1 1/3 gallons per minute. So bathtub B will be empty first. The next page right here, we have put the cars in order from fastest to slowest. Again, note the variables. X is time in hours. Y equals the miles traveled. Assume all cars travel at a constant rate. So car A, this is just telling me 65 miles per hour. Number of hours times 65 will give me the total miles traveled. The Bakers completed the 64-mile trip to Salt Lake City in 50 minutes. So 64 miles traveled is my Y value, minutes is my X value, so 64/50. I'm going to figure out how many miles per hour they are traveling. If they travel 64 miles in 50 minutes, I can set that equal to X/60, and X is equal to 76.8. I did cross multiplication to solve for that. Car C, we have a table. In 2 hours, they've gone 150 miles. In 4 hours, they've gone 300 miles. So we can take 150 and divide it by 2, and 300 and divide it by 4, and we get a rate of 75 miles per hour. And then car D, we have a graph, so we can go up to 40 and over to 1. That's where our distinct point is. So they are traveling at a rate of 40 miles per hour. So fastest to slowest, car B is the fastest at 76.8 miles per hour. Car C is the next fastest at 75 miles per hour. Car A is at 65 miles per hour, and car D is at 40 miles per hour. The next one that we have here is put the exercises below in order from burns the most calories to burns the least calories. Again, we're going to note that the variable X equals time in minutes and Y equals calories burned. So again, we don't burn calories, or time doesn't go by because we burn calories. Calories are burned because the time goes by. So assume the rate at which you burn calories in each of the exercises is constant. Cycling, we're going to burn 10.8 calories every minute. Yoga, Meredith burned 429 calories in 1 hour. So I figured out per minute because that's what our X value is per minute. So 7.15 calories per minute. Running, here we have a table. So I went ahead and divided 137 by 10. 205.5 by 15, 342.5 divided by 25, and each one of those divides to give me a rate of 13.7 calories every minute. And then swimming, we have a graph, so I can find my distinct point, and you can burn 25 calories in 4 minutes. Which gives us a rate of 6.25 calories per minute. So most calories burned to least calories burned. We have running because running burns at a rate of 13.7 calories per minute, then cycling at a rate of 10.8 calories per minute, yoga at a rate of 7.15 calories per minute, and swimming is 6.25 calories per minute. Oh, we're going to Disneyland again. 4 families are meeting up in Disneyland. Each family starts driving from home. The representations below show the distance each family is from Disneyland over time. So each of the families lives at a different distance from Disneyland. So again, note the variable x equals time in hours, y is distance from Disneyland, and again, assume that the families are driving at a constant rate. So family A, we have y is equal to 95 minus 55x. So here we are going, we're 95 miles away, and they are driving at 55 miles per hour. That's how far away they are, and this is the rate at which they are traveling. So family B lives 120 miles from Disneyland and drives at 65 miles per hour. So each hour they're getting that much closer to Disneyland. It'll take them 2 hours to reach Disneyland. Family C, their rate of change is 75 miles every hour and a half, which gives us 50 miles per hour. So they're getting 50 miles closer to Disneyland every hour, and they're 80 miles away. Here's our y-intercept of 80. And then family D, here we have a y-intercept of 45. So they are 45 miles away, and they are driving at 40 miles per hour. So every hour they are getting 40 miles closer to Disneyland. So we have some questions right here we're going to go through. And it says, which family lives the closest to Disneyland? Family D, because they were only 40 miles away. Which family lives the farthest from Disneyland? That would be family B, because they were 120 miles away. Which family is traveling at the fastest speed? That would be family B, because they're traveling at a rate of 60 miles per hour. And part D, which family is traveling at the slowest rate? That would be family D. They're traveling at 40 miles per hour. Who will get to Disneyland first? So in order to figure out who will get to Disneyland first, we had to set the distance to Disneyland equal to 0. So they're traveling at a negative rate because that's how many miles closer they are. So we set each of the equations equal to 0, and then I solved each of them individually. So family A, it'll take them 1.72 hours to get to Disneyland. Family B will be 2 hours. Family C is 1.6 hours. And family D is 1.125 hours. So family D is going to make it there first, and family B is going to make it there last. Let's look at this very last page. It says directions. For each problem, circle the representation with the greatest rate of change. Put a star by the representation with the greatest y-intercept. Assume all representations have a constant rate of change. So this is number 8. So we're comparing the equation to the table and then to the graph. So circle the representation with the greatest rate of change. 3.5 is the greatest rate of change. And the star goes by the second one because it has the greatest y-intercept. If we look at number 9, this one has the greatest rate of change, and this one has the greatest y-intercept of 1. And then number 10, we have circled the 2 points because we have the greatest rate of change is, I think I might have gotten that one backwards. The greatest rate of change would actually be -3 because -3 is greater than -4. But if you're looking at it as how much it's moving, that would depend. The star right here is going to be by this one because the greatest y-intercept is 4. So please let me know if you have any questions on that. This one's a little bit confusing, so let's have a discussion about that.